This is the beginning of Unit 2, Electrons and Light, and going through electron configurations. First, we'll start in the electrons in the atom with just the beginning introduction notes. We have the different location of the electron. There's the principal energy level, which is just the energy level denoted by the principal quantum number of n. If you remember Bohr's model of the atom, he had n equals 1, n equals 2, n equals 3, and 1 was closest to the nucleus, and 2 was the next one out, and next one out was 3, and so on. That just tells us our energy level is the principal energy level, and it's denoted by the letter n. Then we have our sublevels, which are just characteristic shapes which can predict the location of the electron. So the sublevel is just the shape. If central was the nucleus of an atom, where you live, how far away that is would be kind of your principal energy level. You might live 15 minutes away, you might live 25 minutes away. Your sublevel would be kind of the route you take. So you can have different routes around the nucleus of the atom, but the electrons will have those different routes that they follow. They're still going to be doing the same process, going the same place in the end. We have our electron orbitals. They just describe the orientation of the sublevel around the nucleus, which you'll understand in a little bit. The s sublevel only has one orbital. P, D, and F have multiple orbitals based on their orientation. The P sublevel has 3 orbitals. It can fit 6 electrons. The D sublevel has 5 orbitals. It can fit 10 electrons. And the F sublevel has 7 orbitals. It can fit 14 electrons. Looking at that math-minded kids, how many electrons do you think each orbital can hold? You're right if you said 2. They can each hold 2 electrons in each of those orbitals. If we look at the principal energy levels of electrons, remember that's denoted by the lowercase n. N tells you how many sublevels can be found in that energy level as well. So if we go back to the example of central being the nucleus and where you live being the different sublevels, the different routes you take, the closer you live to central, if you live just a couple blocks away, you probably only have one different route. So you only have one different sublevel, one different orientation or route that you can take. If you live a little bit further away, there's probably a couple different ways you can use to get to central. When you have the third principal energy level, there's more space, it's further away, a longer trip around the atoms, or the center of the atom, the nucleus. So you can have 3 different sublevels, 3 different orbitals, 3 different sublevels to go around the nucleus there, and for the 4th principal energy level, you could have all 4 different types of sublevels. Real quick, here's a look at our different sublevels. Sublevel indicates the general shape of the orbitals. The orbital is a region of space, or the orientation, where there's a high probability of finding an electron. If you remember Schrodinger's work, he calculated where the electrons were most likely going to be. Same thing here, you can see with the orbitals, we have a higher idea that electrons going to be somewhere inside that colored or orbital shaded region there. That's just where the electrons are most likely going to be. That's their tendencies. And again, each orbital only holds 2 electrons. We'll go through each type of sublevel and the electron orbitals. We have our s sublevel. There's just one orbital. The s stands for spherical. So the spherical sublevel, it's just pretty much a sphere. And the reason there's only one orbital is no matter which way you turn a sphere, it's going to look the exact same. If we look at our D sublevel over here on the right, it kind of looks like it's called D sublevel for being double dumbbells or diffuse. If you're a weightlifter and you've ever crossed your dumbbells over each other, that's kind of what the look is here. The other thing you can think of maybe is like a 4-leaf clover kind of look. That's your D sublevel. And there's 5 different orbitals. 1, 2, 3, 4, 5. That's just the 5 different ways that you can orientate it. So one's up and down, forward to back, laying flat, laying a different direction, and then this also kind of looks like a person with a life floaty on is what I think. So that's how you can tell those different ones there. Then we have our P sublevel. It only has 3 different orbitals. It gets its name from being a pair of lobes or a principal. It has the 3 different ways that you can turn those pair of lobes. That's your 3 different orbitals for the P sublevel. Then we have our F sublevel. It has 7 different ways. We call it fluctuating or fundamental. So you can see here there's actually 6 different little spots inside there. circles, and just the different ways that you turn it, you can turn it 6 different ways, and then also kind of the same thing as the D, kind of looks like a person, but now they're wearing 2 life vests on them. That's your F sublevel, or your fluctuating and fundamental. Now we're going to go through the 3 different rules for writing electron configurations, and you probably don't understand electron configurations yet because we haven't gone through them, but just follow along with these rules. When we start going through examples, they'll click, you'll understand, and you'll get these down easy once it clicks in your brain how it works. The first rule we have is the Aufbau principle, and that just states that an electron enters the orbital of the lowest energy first. So it deals with the ground state, which is the most stable state of the atom. When we're doing these electron configurations, we're doing all of them in the ground state. Aufbau is German, meaning building up or construction. So pretty much we're going to fill these lower energy levels down here before we move to the energy levels up above. If you owned a hotel with no elevator, this is the way you can think about it. You're not going to make people go to the 5th energy level if you have openings on the 1st energy level. You're not going to make them walk those stairs all the way up. It's going to have bad rapport, and your people aren't going to want to come back. You will notice that some of these orbitals overlap. You can see the 4s is lower than the 3d. That just is because the d orbitals are very complex, and they take a lot of energy to fill, so a lot of times the s sublevel, the energy level right above it, actually takes different lower energy to fill than that D sublevel. So whenever you're doing your periodic table, or if you use this arrow diagram to figure out how to do your electron configurations, you'll know exactly, be able to follow that right along. But just so you know, that's what is going on when we have that overlap. Next we have our Pauli exclusion principle. Each orbital can only hold 2 electrons. And if there are 2 electrons in the same orbital, they have to have opposite spin. So you can see up here, one arrow is going up and one is going down. You cannot have them going the same direction. If they are spinning the same direction, there isn't enough magnetism to hold them in place, and they will fly off and go somewhere else. They have to be spinning opposite directions. That creates the magnetism that holds them in towards the nucleus, and keeps them from flying away easily. So that's our Pauli exclusion principle. Our third and final rule is Hund's rule. It's also known as the rule of maximum multiplicity. Test question, if you guys want to write that down somewhere. The sublevels fill so that the number of unpaired electrons will be maximized. So if you look at this diagram down here, 1, 2, I'd fill those 2 at first. 3, 4, I'm following Aufbau's principle. If I get to, this is kind of like a hotel on this floor. If you have a bedroom, 3-bedroom house, your parents aren't going to make you and your brother share when you have enough rooms for each of you to get your own. So that's the Hund's rule. The kind of cheesy way that I remember Hund's rule is Huns don't like to share bedrooms. That's pretty easy to think about sometimes. If this was a house here, your family is not going to make you and your little brother share a room. You each get your own room until they have more kids, and now you have more siblings. Then you double up. So you can see over here too, you're going to put 1 in each of those orbitals before you make them share. Each of these sublevels here is like its own house. So we do fill the lowest first, but anytime you have more than 1 orbital, so in this case we have 3 connected, or 3 in the 2p, anytime you have more than 1 orbital, you're going to give them all their own bedrooms before you make them share bedrooms. That would be violating Hund's rule on the far right. So next I do have this video for you guys. You can go ahead and watch this on your own time, or if you pull up the slides, you can watch it. She goes through this stuff again. At this point, I'd like you to pause and then practice on your assignment. You can go back to the other video that I've created that talks about the orbital diagrams, and I go through some of those practice assignments with you guys. You're just looking at the number of electrons and filling those orbitals with a number of arrows that equal your number of electrons, following the 3 rules that we've learned about. So if you need to rewind and go back in the video, you can do that as well. Then we're going to put it all together. When you're looking at it, you guys have been doing the orbital diagram where you're drawing the arrows. Each arrow represents an electron. However many electrons you have in that orbital diagram tells you how many electrons are present. If you look up here, that is going to be my superscript. I have 1 that represents the energy level. My S represents my sublevel here, and my arrow there represents how many electrons. I have 1 arrow, 1 electron. Up here I have a superscript of 1, meaning I just have 1 electron in that orbital. We're going to go ahead and add these to your periodic table, but quick look, you can see your periodic table is organized in a logical way to make it easier to do electron configurations and show wherever the valence electrons and all that type of stuff is. If you remember, your F block is down below, but it actually fits right here between your 6s and 5d and 7s and 6d. So if your periodic table was set up correctly, it would actually look like this. Also note that your hydrogen and helium are both part of your S block. That's a common thing because of its properties that they put it over here on the far right with the noble gases, but your helium is part of your S block. Here's a quick look at that again. At this point, go ahead and stop. Fill out your periodic table, drawing, copying one of mine, or looking at the video of how to fill it out, labeling your sublevels. And then when you finish that, make sure you work through the complete electron configuration or do your own practice using the next couple of slides that I will put up quickly. Then you can look at those to do some extra practice on your own. When you're doing those, make sure you follow the periodic table. You're reading it from left to right like a book. You can watch my video on complete electron configuration to make sure you're doing that correctly. Here's a couple example ones. You can go ahead and pause and do these on your own to get extra practice. You can also use the ones on the left to see some more practice ones if you need examples. And then here's again some more practice ones. You can see the examples again on the left. You're doing the complete electron configuration, so that is the one where you have the 1s2, 2s2, 2p3. You write them out with superscripts. The orbital diagrams are always going to have the boxes and arrows. And then once you're done with that, go ahead and stop. This is the end of your first day of notes. Make sure you complete all of your homework before you move on to a new note sheet. I hope you guys figured it out. Don't forget to watch the other videos at the spots that you're supposed to make sure that you learn everything you need.